A few years ago, a single, blunt message started making the rounds on developer forums. You need to stop prompting coding agents directly and start building automated loops to do it for you. Until that point, most people interacted with AI in a strict sequence. You type an instruction, the model gives you an output, you read it, and you type the next instruction. The issue with this setup is that models can generate code exponentially faster than you can read it. Every time the system has to wait for you to review an output and decide what to do next, you become a hard choke point in the pipeline. If you are building a full software application, you are looking at hundreds of interdependent steps. When every single test and logic branch requires human sign-off to proceed, the pipeline fractures. You physically cannot keep up with the model. Tapping into the processing speed of an AI requires removing yourself from the moment-to-moment evaluation. You have to automate the orchestration phase. That is exactly what an agentic loop does. It inserts an automated orchestrator between you and the model. It looks at the current state of a task, decides what the next action should be, executes it, and evaluates the result on its own. But a loop that evaluates its own actions needs a strict set of rules for when to quit. These are the stopping criteria, often a formal test suite or a hard iteration cap, designed to prevent the system from burning compute resources indefinitely. The concept is rooted in the basic programming while loop, but it gained traction in 2022 with frameworks that forced AI models to alternate between explicit reasoning steps and action steps, rather than just executing commands blindly. We saw what happens without those strict boundaries a year later with AutoGPT. Developers gave the model a broad goal and let it run, but without objective stopping criteria, the system suffered from the toy agent problem. It got stuck in endless circles, rocking up massive token costs without actually shipping useful code. Today's systems survive by using a disciplined loop. Instead of letting the model drag around a massive, confusing history of its past mistakes, the orchestrator clears the history at the start of every iteration. It feeds the model the original goal alongside a fresh summary of the current state. To be clear, agentic loops are not magic boxes. They are rigid engineering systems that only function safely because they are heavily constrained by the failures of early AI experiments. Critics frequently argue that an agentic loop is nothing more than a standard cron job, a basic time-based scheduling script with some AI branding slapped on top. And they do share the exact same scheduling infrastructure. This chart shows the critical difference. On the left, a cron job executes the exact same fixed script every time it triggers. On the right, an agentic loop possesses a decision-making body. It looks at the test failures, reasons about the specific bug it encountered, and adapts dynamically to solve it. Because the loop is making dynamic decisions, you run into the problem of confident mistakes. An AI will frequently produce code that looks perfect, matches your formatting, but is entirely broken. To catch these errors, you have to enforce the independence principle. The model that writes the code cannot be the entity that grades it. If it grades its own work, the same reasoning that led to the bug will cause it to approve the bug. Instead, you use an independent test suite. When a test fails, you don't just tell the model to try again. You feed the exact stack trace and error logs back into the model, giving it the specific failure data it needs to converge on a working solution. Deploying autonomous AI without this strict, independent verification turns it into an active liability. That liability scales up quickly when developers try to run dozens of loops simultaneously. There is a persistent myth that spinning up massive fleets of parallel agents translates directly to massive productivity. But in practice, you hit the orchestration tax. A dozen AI agents can generate hundreds of complex code changes in an hour, crashing against the reality of your review bandwidth. If you only have the capacity to carefully review 10 changes a day, the rest of that automated output is useless. If you merge that unreviewed code anyway, you create the understanding gap. The software works, but you no longer know exactly why it works, how the architecture fits together, or what hidden dependencies the model introduced. Because you cannot oversee every step in real time, the role of human input shifts. Prompting has evolved into the seed prompt, concentrating all of your architectural intent, test cases, and constraints into one initial block. If the seed prompt is vague, the loop doesn't ask for clarification, it makes a guess. And because the loop runs continuously, it bakes that error into every subsequent iteration, turning a slight misunderstanding at the origin into massive architectural drift. Once the loop starts, you lose real-time oversight. Heavy, precise, upfront engineering in the seed prompt is your only defense against a cascading failure. That cascading failure has a very literal price tag. Models charge by the token. If an open-ended loop decides to refactor your entire codebase to fix a single bug, it will generate tokens continuously and drain your budget overnight. This is why production systems require a hard spending limit. You define a monetary cap and build in automated progress checks so that if the loop is burning tokens without getting closer to the goal, the system forcefully shuts it down. But containing the risk is just the baseline. The real payoff comes when you realize the loop mechanism itself is just temporary infrastructure. It does the work, but it isn't the final product. When a loop solves a difficult problem, you extract the specific diagnostic steps and formatting rules it used, and you encode them into a named, reusable instruction set. In loop engineering, this is called a skill. You attach these skills to your future seed prompts. The second project benefits from the lessons of the first, and the 10th benefits from the 9 before it. The system accumulates knowledge and gets smarter over time, even if the underlying AI model remains exactly the same. Rigorous architectural boundaries and compounding skills transform the loop into a permanent asset. The practitioner moves from operator to architect, managing a system that grows more capable with every completed task.